Welcome, everyone. This is the fifth webinar of a series of webinars that together create a workshop called Reducing the Health Impacts of the Nitrogen Problem. This workshop and series of webinars is being organized and presented by the National Academy of Sciences under the auspices of the Environmental Health Matters Initiative. If you missed the first four webinars or are interested in re-seeing them, they are available on the website after, as will this one after it's completed. So there will be availability for anyone who wants to go back and look at those webinars. For those of you who have attended one or more of the previous sessions, you know that there has been a very active and informative Slack communication. If you look below your screen, you should be able to see a place where you can sign in and begin to participate in Slack. And we really encourage you, as we have in previous times, to participate that way. We've gotten lots of great ideas, made lots of connections, all of which contribute to the communication goals and ultimately solution pathways to which this workshop is intended to contribute. Today, as I said, is our fifth and final workshop. My name is Kathy Kling, and I will be kicking us off. I have been the chair of the organizing committee, and in that capacity have had a lot of fun welcoming you all and concluding the workshops. Today, I'm going to welcome you again and provide a bit of an overview of what we've learned to provide context for the rest of today's 3-hour webinar on solution pathways. If I could have the next slide, please. This is the remainder, the others on the organizing committee. You've heard from, seen some or all of them previously. Alina Austin from the University of Washington, Jerry Hatfield from USDA, Jim Galloway, University of Virginia, Jennifer McPartland from EDF, Robin Wilson from Ohio State, and Raj Khosla from Kansas State. In addition to myself and this group who've been active in organizing the committee, we've been extremely fortunate to have a very productive and helpful academy staff. They've really done the bulk of the heavy lifting throughout this entire process, both in terms of logistics as well as in terms of content. So I really want to thank Kara Laney, Janelle Walsh-Thomas, and Sarah Harper for their enormous contributions and efforts. Next slide, please. Today, as I said, it's the fifth of a webinar in the workshop series. Once I do a bit of an introduction to, again, provide more context for the discussion today, I'll be turning it over to two of those organizing members, Elena Austin, who you just saw a picture of, and Jennifer McPartland. They will also be contributing to some reviewing, and then they will be coordinating and engaging a panel, a set of panelists. The names and the topic areas you see listed here. So we'll be talking about potential pathways regarding technical tools, Steve Hoffman and Carl Rockney, behavioral tools, Tom Hurdle, knowledge gaps, as we think about what we need to know to make progress, Bonnie Keeler and Ken Kassman. And finally, you'll see me again with some concluding remarks. Next, please. But before I turn it over, we thought it would be constructive to remind people of some of the sort of overarching components of what makes nitrogen issues in agriculture so challenging. So I pulled some information in the next few slides from a whole series of the previous talks we've had over the last 4 weeks, and I came up with a set of takeaways. I want to emphasize that these are my takeaways. They don't represent agreement by the entire committee. We will be producing a synthesis report, a short report that will be available this summer that we'll have some takeaways and key ideas that are more representative of the group. But for right now, I'm hopeful that this will help us as we discuss impact pathways for the next 3 hours. So 6 key takeaways, I'm going to list them and then I'll give you a little bit more background on them. Number 1, driven by competitive markets that incentivize yield and profits, nitrogen fertilizer remains a critical input to production. And I should add, the production systems of agriculture in the US are second to none. It is a highly productive system. 2, unfortunately, that production system leaks nitrogen. It's been said to be similar to millions of small, drippy faucets that unfortunately are all directly channelized through hydrology into our waterways. 3, the full social costs of these nitrogen losses are incompletely understood, but our knowledge base is growing and we have enough information to be concerned. 4, the technology to plug these leaks exists, but the most effective types of practices are not broadly implemented currently. Federal and state policies also exist and have been very active in some ways, but unfortunately are not designed to address the scale and breadth of the nitrogen problem. And finally, private sector and NGO leadership has been very important and developed some innovative programs that hopefully we can learn from. Next. So again, just a bit more context. Takeaway 1, we have a very large and productive agricultural system that uses nitrogen fertilizer extensively. On the left, you see a map of the footprint of farmland in the United States. The key point here is that there is an enormous amount of land that we use for growing our crops, food, fiber, and in many cases, fuel. Ethanol is an important output. That productive system uses a lot of fertilizer. And on the right, you can see in dark blue are the areas that have the highest intensity of fertilizer application from both commercial and animal sources. And you can see that, of course, it overlays pretty directly where agriculture is, and it's pretty extensive. Next. Our production system, unfortunately, leaks nitrogen. And as I noted, it's similar to having millions of small drippy faucets channeled into our waterways. And unfortunately, it is millions because we have millions of acres of agricultural production. If you look on the right, you'll see a picture of what much of that agricultural land looks like during the year. We have taken a perennial-based historical landscape and turned it into an annual landscape, which means that for 8 or 9 months a year, all of that or much of that agricultural land is barren. That makes for a very leaky landscape. There is nothing living there to absorb or uptake nutrients, particularly nitrogen. That's been made more problematic by the tile drain systems that have been installed over millions of those acres. This tile drain system is represented on the left, where we literally have put tiles into the land, making drainage very effective in moving excess water off land. You see the pipe at the bottom coming off of an ag field. This has been incredibly productive in terms of yield and growing things. Unfortunately, it has had this extensive side effect of channeling nitrogen into our waterways. Next. We also heard about that channelization and where nitrogen is ending up in our groundwater, both shallow and deep, for drinking water, and therefore in terms of wells. And again, if you start to notice these maps, you're seeing common footprints, areas of the country that are intensively agriculture, where intensive amount of nitrogen fertilizer is used, and where we are seeing drinking water and water quality issues arise. Next. This is, again, just another picture to confirm that that's where that large swath in the Midwest, as well as some of those agricultural areas around the country, is where those tile drains have been extensively installed. Next. We're going to hear a bit more about this shortly from Alina, but we heard about some of the costs of those nitrogen losses. This is a picture that was shared just from the state of Iowa, where there is some data availability on private wells from Iowa's Grants to Counties program. The data collected there is represented here with each of those red dots being a well which had nitrogen levels tested at or above 5 parts per million. Of the 12,000 that you see dots for, about half of those wells are indeed testing above the 10 parts per million, which is the health standard set by the Safe Drinking Water Act. Next. We, in fact, do have the technology to control these leaks. We heard from Jane Frankenberger and others from Iowa State about a variety of really interesting approaches. One thing we learned is that while better fertilizer management is very important, even with spoon feeding, even with the best fertilizer management, we will not eliminate the continuous drip of nitrogen that is behind the problem, largely due to the fact that we have this now highly annual system where so much of the ground is bare throughout the winter and a good chunk of it is tile drained. Some nitrogen is always going to leak. However, we do have technologies that would eliminate those leaks. You see a couple pictures here on the right. Drainage water recycling, which is a way of taking the water and reusing it and putting it through recycling. On the bottom right, there's a picture of denitrification bioreactor. Some really neat work on prairie strips was shared, constructed wetlands, and many others. Unfortunately, those approaches that are the most effective for controlling nitrogen in many parts of the country are money losers. And there is simply not an incentive to adopt those practices. And in fact, farmers who compete to stay in business cannot afford really to take on additional costs, such as those kinds of systems require. We also heard over and over again of how important it is to acknowledge and recognize that solutions need to be matched to local agronomic and economic conditions. We heard about cover crops in the East, which is very different than cover crops in the cold, wet Midwest. We heard about Florida agriculture. We heard about drip irrigation systems, which is extremely different than the systems we have where there's extensive rainfall and we need to drain water off of land. So this is going to be it needs to be a very place-based focused agenda, however we address this problem. Next. We heard about federal and state policies. We heard about some of the successes of those policies with respect to many areas, but we also learned that some of those policies are really not designed to address the scale and breadth of the nitrogen problem. The Clean Water Act regulates water pollution from industry, but exempts most of agriculture. The Safe Drinking Water regulates drinking water from public and community systems, but excludes private wells. We also heard about federal agricultural conservation programs, the Conservation Reserve Program, conservation compliance requirements tied to farm subsidies, especially crop insurance, and the swath of working land programs supported by federal taxpayers EQIP, CSP, state programs. And as effective as those programs can be, it turns out that we don't target those programs as well as they could be, particularly for the types of solutions that will be required for nitrogen. Next. Finally, we heard some very encouraging and innovative ideas from private sector farmers and producers, as well as NGO leadership. They've developed a number of local innovative programs that show success and promise for more success. I've listed a few examples of what we heard about. TNC is developing the market value of manure, some really important work in the Raccoon River Watershed Alliance. Iowa Soybean Association has been a leader in this area for a long time. We heard from a farmer panel and heard directly from some farmers who have very strong conservation ethics and were able to share their reasons and logic for the steps that they have taken on their land. Finally, we've talked about supply chain certification and water quality trading programs as a possible bridge between private and private sector incentives. We learned that those are, as currently constituted, not probably well suited for this problem, but that they could, with policy change and other changes, hold significant promise. Next. With that, I hope that that has been a constructive context to continue our discussion today. And with no further ado, I'm going to pass it on to Elena. Thanks all for joining us again.
I think I'll wait for my slides to go up. So today I'm really going to be summarizing some of the discussions we've had in previous workshops about the exposure pathways and health impacts of nitrogen. And the goal is to present a short summary of what we do know and identify some of the knowledge gaps that we may discuss in the third discussion session today, with the view of having these knowledge gaps being filled and contributing to the solutions. Next slide. So to frame the discussion of health impacts, I wanted to present here an exposure pathway from the emission or the release of nitrogen to the soil to our outcomes and human health endpoints. And what we're really going to be focusing on in this short summary are the exposure points for nitrogen, the exposure and dose of nitrogen, and then I'll provide a short review again of some of the health outcomes we've discussed. And throughout this, highlight some of our knowledge gaps, both in terms of potential disparities in exposure and outcome, but also just in terms of the water concentrations that are contributing to these. Next slide, please. And a lot of the content that I'm presenting is a review of materials presented in our first workshop, so workshop 1, particularly by Mary Ward and Craig Cox. And I invite you again to go back if you didn't have a chance to participate in that workshop at the materials and video presentations. Next slide, please. And so here's a slide that was prepared by Craig Cox and the EWG group, looking at water systems that are public water systems, so serving 25,000 or fewer people, that had yearly test results that were above 5 milligrams per liter of nitrate as nitrogen, which is the EPA criteria for it's an action level for responding. And you can see that the distribution of these water systems overlays quite well with agricultural production and some of the slides presented by Kathy. And so there is, of course, this association between the source of the nitrogen exposures and the exposure at the water level in these public systems in the communities. Next slide, please. One of the important knowledge gaps that I want to highlight is the impact of exposure through private domestic well supplies. And so this is an estimate developed by USGS of the number of the locations of individuals served by domestic well supplies. And that total population is estimated to be 40 million people in the US, but the characteristics of those populations, as well as the well stewardship or characteristics of those wells, is not something that is known. And so that is a knowledge gap that exists. Next slide. What we do know is that based on measurements of waterways as well as groundwater, we can estimate the predicted nitrate concentration in deeper groundwaters. And this predicted nitrate concentration in deeper groundwaters would be correlated to the concentration that we would expect in an untreated well in those particular locations. And again, here we have a distribution of those predicted groundwater concentrations developed by USGS now probably about a decade ago. And again, you can see in red on this map the locations where the concentration of nitrate as nitrogen is above the allowable limit, and in yellow, the locations where there's evidence of human impact and is well above the action level. So individuals in those locations whose water may be impacted by nitrogen would be expected to follow different well stewardship behaviors and additional testing. And so the highest exposures for individuals are for residents of agricultural areas. So again, I hope you're seeing here the distribution and patterns of these nitrate concentrations in groundwater overlap somewhat with agricultural production, although it is also related to the geology and soil characteristics of particular regions. And then as a reminder, the private wells in these locations, in fact, throughout the US, they're not regulated, so they are permitted at the point of installation, but beyond that, the well stewardship is not regulated. And there's very sparse measurement available of the concentrations over space of nitrate in these well systems, and particularly there's no knowledge of the concentrations in these well systems over time. All right, next slide. And so who's being exposed? And so when we think about who's being exposed, there's quite a bit of evidence, and Kathy presented one of the summary slides on disparities. There's quite a bit of evidence that nitrate contaminations in public drinking waters as well as in private drinking well waters disproportionately impact Latino communities. And that's primarily driven by the fact that 83% of farm workers are Latino. So there's overlap in the spatial distribution of Latino populations as compared to the spatial distribution of nitrate in groundwater. And a question that I want to highlight here is, are there disparities in exposure primarily among private well water users? And the answer to that question is not easy to answer because, again, we have this lack of information on the exposure in private well water users and of the exposures over time, of the concentrations. But we also have a lack of information on well stewardship. And so there are well stewardship that can be conducted to protect individuals using those well waters, even if they do have concentrations of nitrate that may be above the action level. But we have no information on whether those behaviors are being followed. And we also don't have information on treatment. Next slide, please. And so what is the impact of having nitrate in the environment? And so the primary route of exposure that we're going to be talking about is ingestion. And there are three main sources. So nitrate does naturally occur in food. And so that is one route of exposure. It can be a food additive, as a preservative for certain items. And then, of course, when water is ingested that contains nitrate, that's another source. And then internally, the ingested nitrate or nitrite, which is a reduced form of nitrate, is converted to nitroso compounds. And these are the compounds that are associated or that are thought biologically to produce negative health outcomes. And so, as Mary Ward presented, the EPA MCL for nitrate exposures in water, which is set at 10 milligrams per liter of nitrate and nitrogen, is set to ensure that there's no excess formation of these nitroso compounds internally. Next slide, please. And the most immediate impact of exposure to nitrates in water is blue baby syndrome. And this is a fairly rapid response, typically is seen in infants under the age of 6 months that were exposed to concentrations in the water above the EPA MCL. Mary Ward discussed often 2 or 3 times above the EPA MCL. And then there are other outcomes that are associated with nitrate concentrations through epidemiology studies. And they include adverse reproductive outcomes, some cancer outcomes, as well as hypothyroidism. But these outcomes, because of the difficulty in the exposure assessment, so in assigning exposures of nitrates to populations and particularly to private well users, the associations are not currently considered causal. So there's more information that needs to be developed to determine these associations in the future. Next slide, please. Kathy reviewed some of these, but I want to touch on them again. So currently, the federal regulations that apply to controlling human exposures to nitrates include the Federal Clean Water Act, which regulates point sources, and some large animal operations in agriculture, but most other agricultural operations are exempt. And then the Drinking Water Act, which regulates the concentrations of nitrate in public systems and establishes exposure standards, but unfortunately exempts private wells from this required yearly monitoring and treatment. Next slide, please. And so in summary, we've discussed the exposure pathway of nitrogen and how it comes to be causing health effects in our communities. And what I hope that we can discuss later today is how we move through this paradigm of exposure to health to understand the social costs, prevent the social costs, and think about how to consider some of the knowledge gaps that we have in this space and move forward to enhance our solutions related to nitrogen usage. So thank you. And I will pass the session along to Jennifer McPartlin, who will summarize some of our other contexts that we've talked about. Thank you.
We're waiting for, thank you, Sarah, for sharing the screen. Well, thank you everyone for joining us in this final workshop in our series. We're going to spend the rest of our time together taking stock of what we've heard over the previous workshops and really focus in on what we can be doing now and in the near future to tackle the public health challenge of reactive nitrogen in drinking water as a result of fertilizer use. And so to do that, we've organized the afternoon session into 3 discussion sessions, each focused on a different solution pathway. And those are listed here. So we'll have some discussion first on technical tools that may be available or are available to address the nitrogen challenge. We'll then talk about leveraging behavioral tools to include both market policy and related types of interventions. And then lastly, as Alina was indicating during her remarks, we'll spend some time talking about the key knowledge gaps that we can be working to address as we move forward in implementing solutions. Next slide, please. Okay, so for the first session, as I just said, we'll focus on technical tools. And for those of you who weren't able to join us throughout the series, a lot of these tools were actually discussed in the first and second workshops, where we heard presenters speak about opportunities around more precise end application, leveraging advancements in digital agriculture, and integrating innovations, including nitrogen sensors, microbial Haber-Bosch, and technologies around automated end application. We also heard ideas around mimicking or restoring natural landscapes, including activities such as diversified crop rotations, integration of prairie strips, use of perennial grains, as well as wetland restoration. Lastly, we heard several great presentations on edge-of-field practices for better water management. And some ideas that were presented included controlled drainage, 2-stage ditches, retrieving drained water for irrigation, and use of saturated buffers and bioreactors. Next slide, please. Okay, so shifting then to our second session, where we'll be focusing on behavioral tools. What we heard largely during workshops 3 and 4 were various activities and efforts to motivate behavioral changes by various actors, including but also beyond farmers. And so some of those ideas and discussions were around better targeting of funds in terms of practices, geographies, and cropping systems. We heard quite a bit about organizing farmer collaborations. We heard specific examples of such collaborations occurring in Florida and Iowa and California. We had some discussion around leveraging supply chains as a strong demand signal for better nitrogen management. We talked about focusing on the development of compliance or performance metrics for better land management. We had a presentation around rethinking water quality trading markets. And finally, we had a discourse around directing funding to watershed scale conservation efforts. Next slide, please. Okay, and so lastly, our third discussion session is going to focus on key knowledge gaps that we think would make a significant difference, significant impact in forwarding our efforts around nitrogen management and the associated public health challenges. And so among the knowledge gaps that were identified were quantifying the social cost of reactive nitrogen, much along this sort of the same framework as the social cost of carbon. Quantifying the critical values of nitrogen for soil and plant sap during a given crop's growing season, and lastly, monitoring reactive nitrogen releases from fields and its presence then in waterways and drinking water. All right, next slide, please. So at this point, we're going to be jumping into our first discussion session that's going to be focused on technical tools that are available today or could be available in the near future. And for that discussion, we're going to kick it off with two discussants, Steve Hoffman and Carl Rockne. And I will just briefly introduce them. Steve Hoffman is president and managing agronomist at In-Depth Agronomy, which is a crop consulting company based in Minnesota. He is a member of the National Alliance of Independent Crop Consultants, serving as its president since 2017. And we are also joined by Carl Rockne, who's currently serving as the director of the Environmental Engineering Program at the National Science Foundation. And he is also a professor in the Department of Civil and Material Engineering at the University of Illinois at Chicago. Next slide, please. We've asked our discussants to tackle the three questions that are presented here on the slide. And in thinking through both the technical solutions that we've identified through this workshop series, but also others that they may be aware of. And so, Steve, if you could kick us off with some remarks, and can we also go back to the previous slide so that the audience can see which technical solutions have, yes, thank you so much. Okay, Steve, to you.
Thank you, Jennifer, and thank you for the opportunity to participate in this. So, as an agronomist standpoint, just some background, I work as an independent crop consultant in eastern Wisconsin with mostly dairy farms. Just for some background there, that's what I've done for my whole career. And I've struggled with nitrogen management for my whole career and still struggling, and excited about the future, but I know we've got big challenges. So as far as precise application and the tools we have there, really with nitrogen, what I found in crops is it's not enough to just measure the soil status. It's not enough to just measure what the plant's telling us. We've got to measure both of those things in several different ways, whether it's through plant sap, a tissue test, a soil nitrate test, maybe NDVI, or maybe an actual chlorophyll measurement of the leaf. And at any given time, we need to be able to use any of those tools. And for instance, I've done some work this past year on putting some soil tubes in the ground, extracting soil water, and measuring the nitrate level of that soil water at 12 inches and 24 inches. And I quickly learned through that on several fields that just reading what the soil is telling us is not enough. We got to also know what the plant is telling us. So I know in the last part of this session, we're going to talk about knowledge gaps and developing those critical values for soil nitrogen and plant sap. That's key as part of that. So as we heard earlier in these sessions, it's just plain not an option for a corn farmer to run out of nitrogen during the season. And it's kind of like driving a car from here to Colorado without a gas gauge. That's kind of what I think of the nitrogen situation right now for a farmer. We just don't have the adequate tools that we can trust to know we're going to get there and not have too much gas left in the tank, because in the eastern, humid regions, that extra nitrate left in the soil is going to either denitrify or leach. So better tools, definitely. And then as far as any microbial help, that Haber Bosch, that sounded very promising. I know there's other microbial products that are put on to the plant, either at planting time, that might help fill a gap, might give us an extra 20 pounds of nitrogen. That might be enough to kind of fill a gap until that root system expands. I think those are very promising. Automated application falls into that same category. It's very promising, but until we have the exact information of, spatially, what is the soil telling us, are the plants telling us, until we have that information, we don't have enough to really use automated application fully. To go along with that, because nitrogen is so, it exists in so many forms, can change from day to day, and any one of those tests is just a snapshot in time. If we get a big rain event, we know we can lose nitrogen through leaching or denitrification. So I feel what would be a big value is a model. And I know they exist. I think the problem with the existing models is they're not adaptive to the situation. I think a model needs to adapt itself to that farm. So in other words, we use a soil test, we use a plant test, and we use a model. And once we get a reading from the soil, we plug that into the model and have that model self-correct. And maybe the model was predicting, 7 parts per million, and we got 15. So the model self-corrects itself, and over time learns that soil on that farm in this management system, the model forms itself to that particular situation. I do believe there's great promise in models, but I think if we think about all the variation between from farm to farm, tillage systems, manure, there's just so many variables that to expect a model to take all of that into account just is not practical. And as far as the natural landscapes and edge of field practices, I'm actually manage two farm networks through NRCS and the Great Lakes Restoration Initiative. That the idea is to have farms do no-till cover crops, all these kinds of practices that are good for water quality and soil health. And I really truly believe that having a living root on the soil at all times is going to really address a lot of these problems. I really truly believe that soil health is a real thing. Nutrient cycling is a real thing. And like we heard in one of the earlier sessions, there's very promising data coming out of that. So I would leave my comments to that for now then.
That's great. Thank you so much, Steve. We'll now hand it over to Carl before opening it up for group conversation. Carl?
Okay. I don't know if you can, I hope you can see me. There we go. So I kind of focused on this list from the context of answering the three questions: what is missing, which one should we prioritize, and how can we operationalize these tools? And probably, in anything, it's always easiest to find what's missing, right? But there's a few things that I haven't seen yet, but there are things that I see on the horizon, but also considerations in all of these. And first of all, I think that all of these have to be taken into consideration within a framework, a systems approach framework. So, we have to ensure that if we do one thing, it's, depending upon where you draw the box, it might be good or it might be bad. You have to look at the entire system to understand whether things are working. And the focus of EHMI obviously is on environmental health, but I think this is a situation where, human health goes hand in hand with ecological health, and that measures to protect the environment are going to end up also protecting human health. In particular, I'm thinking that, many of these things are focused on preventing overloads, having more targeted delivery so that what you deliver is used up and there's not all this runoff, this leakage that was talked about. But I don't think you can only focus on that. I think that you have to have other measures that will continue treatment after release. And that could be looking at things like the picture that was on the slide just before this showed a nice drainage ditch, an agricultural drainage ditch. They're all over the Midwest. And focusing on these not as just means of moving water, but really as treatment reactors. Certainly, in addition to that, I think there are some technologies that we are investing in at the National Science Foundation, for example, that I think could be considered as well. I love what's being looked at microbial Haber-Bosch, but also let's not forget there are abiotic technologies looking at not just nitrogen fixation technologies, looking at metal catalysts, for example, like pyrite, but also as nitrate removal technologies. So they get both the source end of the equation as well as taking care of any residual nitrates that leak out of the system necessarily through inefficient capture and use by agriculture. In addition, I really, really want to emphasize, on the talks, the great talks that were focusing on exposure. One of the key things you found was that exposure as captured by Safe Drinking Water Act, data, for example, is really, really hit or miss and mostly miss. And that's because we really, really have to time the delivery of nitrogen to when it's really, really needed by the plants. And in the same way, I think that these technologies all need to take that into account, looking at, spring dressing, for example, spring dress applications versus fall applications, and really tying in when it's needed most. From the second question, which one should we prioritize? In addition to my research, we work with a nonprofit that has a really great network of working with farmers. They're called the Wetlands Initiative, and they really are the face of our efforts in looking at nitrogen removal, specifically through treatment wetlands. But one thing you learn when you talk to the farmers is that they have really their considerations really, really, really need to be taken into account. In a lot of ways, many of these technical solutions are not the limiting step here. A lot of these are social, behavioral, and economic considerations, and I know they'll be discussed a little bit later. But really looking at many of these technologies, we have to keep in mind how they're going to be adopted by farmers and ways to make them cost effective, as was mentioned earlier. If we have a really, really high value product like in viticulture versus, maize, that is completely different. The cost structures are completely different. And so all of that needs to be taken into consideration. And I know there was wonderful talks earlier about, paying for this on a larger level, not making the farmer pay for it, but reimbursing for the ecosystem services. And I think that goes hand in hand with this idea of a systems approach. All of these are costs of making, food from agriculture, and they really need to be considered. Agriculture, like many other businesses, they when you can do it, you try to maximize your profit, and one way to do that is to privatize the profits and socialize the costs. But this is a situation where I think all of society benefits, and really better ways of doing that need to be considered. Some other things I would like to emphasize: sensors. I think that's key. Those data are going to be more and more necessary for precision agriculture, delivering the nutrients when they're needed. We and many other federal agencies are investing heavily in this technology. There's been major efforts such as sensors in the soil that have looked at ways to create large data streams using plants as sensors. One of the things we found is that it's very, very challenging to understand the subsurface, in particular the subsurface microbiota in the rhizosphere. And we know that that's quite critical in having not just adding fertilizer, but making sure the fertilizer is in a bioavailable form, and looking at that whole system, the plant, the rhizosphere, the microbiota, all of that needs to be taken into consideration. And finally, in this operationalizing things, one of the things that we do know in our work with treatment wetlands is we're emphasizing that that farmers should be investing in heavy agriculture in the areas that are most profitable, but looking at marginal lands for conservation practices. In our wetlands, for example, we focus on areas within farmers' fields where it's marginal, it's not highly producing, but could be a place where we might have a treatment wetland to capture tile drainage, for example. So I think that that's one of the big things to consider. As has been mentioned, tile drainage is a huge issue, and it's thought that with greater climate change, tile drainage is only going to increase, and that needs to be taken into consideration. This rapid export of water, we might have solutions that work today, but if we continue to do more and more tile drainage, that could change conditions. And any solution is going to need to take that into consideration, as well as need to be low maintenance and cost feasible. So those are some of my broader thoughts on the 3 bullets about what is missing, which should we prioritize, and how can we operationalize these tools.
Great. Thank you so much, Carl, for your thoughts here and perspective. It was very interesting to hear about the work that's being done at NSF. So at this point, we're going to open up for discussion amongst the group in the Zoom room. And then I also would like to remind people that we have a very vibrant and active Slack channel, and certainly you could be using that to sort of weigh in on the conversation. And I see already that we have Jerry would like to comment. So if we could get him spotlighted.
I can turn my camera on, but Carl and Steve, thank you for your comments and everything. And I, you do address the aspect that the nitrogen is a tough nutrient to manage and everything else. But just going back to this, and I'll put it in this perspective, is what attributes would you put on an ideal sensor?
Do you want me to take that one first? So, okay, I'll jump in. So, when we look at what we want to know to interrogate any environment, we might try to categorize the data, right? So let's look at it from a scientific standpoint. So there's physical information, physical data, biological data, and chemical data. And, I would say that sensor technology has been more advanced in the physical and the chemical side than the biological side, as far as low cost, low maintenance in the field type of technologies. Certainly in the lab, we can do, you know, a lot of these quite well. And obviously with molecular biological techniques, it's really amazing what we can do. But, you know, we supported a series of workshops trying to address ways to understand biology better in the field. And it's definitely been harder because a lot of those techniques are, you know, they require a lot of preparatory steps, reaction steps, reagents, etc. But advances are being made. There's been great investments across really all of the federal agencies. There's a lot of interest, not just at NSF, but USDA, NIFA, ARPA, et cetera. So, you know, with those investments comes advances in the ability to do that. I think some of the things that excited me personally, you know, when we were supporting research in this area was, look, a plant itself is a wonderful biosensor. It directs its growth oftentimes into the subsurface exactly where you want to get at to understand what's going on. And so I think a lot of really interesting efforts have been looked at to turn plants themselves into the biosensors. But you know, to get the types of data we need, you know, I think that it's a multi-pronged problem. I didn't realize this, but for example, it's quite difficult, challenging to send data through soil. But a lot of changes have been made in that. Distributed sensors, low-cost distributed sensors that you can literally mix into the soil and then allow it to sit there and just cast data. And they're so low in cost that certainly, you know, some will lose their ability to transmit data, but you've got sufficient numbers of them that you're still understanding the system. And, you know, we've seen it across so many other fields, right? More data analytics allows us to make systems and processes more efficient. And, you know, as costs come down, we can improve ag in that way too.
Great.
Steve, that one of the things that being a practicing agronomist, what's it going to take to get producers to adopt some of these new technologies? I know we have stabilizers, even the simple thing of split applications. I mean, do those need incentivization, or do they need some regulation to improve nitrogen use efficiency?
I think you're muted, Steve.
I apologize for that. As you know, Jerry, we've got this age-old problem of we can either spend more money on a technology that increases nitrogen use efficiency, or we can buy a little more nitrogen and you know, make sure we make it to the end. And because of the implications of a field running out of nitrogen, you know, I think every farmer in the world knows what happens when his crop runs out of nitrogen, and it's just not something that can happen. So of course, farmers are going to tend to want to make sure there's more than enough. But at the same time, they are also interested in increasing nitrogen use efficiency. With these projects I've been involved with demonstration farms and cover crops, it quickly almost becomes a competition. Farmers, you know, compare notes that, you know, I was able to produce X number of bushels of corn on, you know, less than 1 pound of nitrogen per bushel. And so it definitely engages farmers that we can be more efficient. So I think that that's one of the things, is this whole soil health, nutrient cycling, like I said, is real, and it gets farmers engaged. As far as the sensors question, I would like to know at several depths, you know, what is the soil nitrate level in real time, and as part of that, also be able to tell what soil water is telling me, which would give me good clues as to what rooting depth is for my crop. then I could start to make some pretty good decisions. And like I say, several of those need to be put into different zones within a field. I also would like to know what that plant is telling me. I have good visual, can measure the greenness, but unfortunately on corn with NDVI, I've got to let that canopy develop quite late. You know, I'd like to be making decisions much earlier than that, you know, on ankle high corn or thigh high corn, not waist high corn. So I guess that's what I have.
Thanks. Thanks to you both. I see that Ken would like to weigh in with some thoughts. Ken Kasman? Ken, I
You're
think you're muted.
Yeah.
Thanks for the comments from the group. My question concerns how to effectively prioritize amongst all the things that we've seen. I mean, the list is impressive, but some of them, if you look, are blue sky in the sense, you know, the one about the nitrogen fixing leaf or something. Others are much more practical. We have the ability to go out and adopt them immediately. So if you have and yet we're in a race against time, really. I think that's something that we've got to acknowledge here. This isn't open-ended. It's not as if the trends are not good. Population's growing, demands on natural resources and environmental quality and health are increasing. We've got to use limited resources, even a well-funded national, state, private, public program, going to be resource limited because it's so large. So I guess my question is, number one, how can we do a better job of prioritizing? Because I've been in this business now 50 years, working on the nitrogen problem. I must say, looking back, it's real hard to say, here's what we did, we spent money on research, and here's the result. Very difficult. And so we need to do a better job. The second is, I worry that we often mix blue sky research with applied research when we have grants. So I think we've got to be careful having competitions for funding that include both very basic and very applied projects. They need to be the very basic projects like getting nodules on cereal crop or artificial nitrogen fixing leaves. They have to compete against themselves, and then the more applied solutions are competing against themselves in the shorter midterm range. But what does the group think? How can we do a better job on this? Thank you.
Thanks, Ken. Those are great questions. Carl, Steve, please.
Well, I guess I can jump in regarding what I believe the question was is, you know, different scientific approaches competing against each other. So, you know, if you're talking about a federal level, you know, my own research in this space has not been funded at a federal level. It's been funded at a state level in Illinois, where corn is, you know, a huge, you know, the crop. So, you know, from that standpoint, that's been supporting it. But at the federal level, we do have to recognize that different agencies have different missions. At NSF, our mission is indeed very, very basic science, and we are not a programmatic agency. So the ideas themselves come from the community. They are not part of our mission, like say a DOE or USDA. But I would argue that you know, the question is all based upon prioritizing and making these operational. And as I mentioned earlier, a lot of the limiting aspects are not just technologies, but they're social, behavioral, and economics. And a lot of that is those overcoming those hurdles requires basic science in social, behavioral, and economic sciences. That's what I would argue. And so, we, for example, has one of our 7 directorates at National Science Foundation is social, behavioral, and economic sciences. And understanding those limits, I think, needs to go hand in hand with some of the blue sky technology, as you call it. I agree. But all of this goes into my viewpoint that from a system standpoint, there's not going to be one magic bullet. I think there needs to be multi-pronged approaches to solve this.
Steve, do you have thoughts you'd like to share?
Yeah, I think one priority that was mentioned is the cover crops and soil health. And I know it's been around for 10 years. There are certain parts of the country where it's really taken off, and then certain parts of the country where initially, like was mentioned in the arid West or maybe in the North, that maybe it doesn't have a fit or it's just too difficult to make it work. But I'm in one of those cold, wet areas that we struggled, but we're finding systems that work. And if we can keep working towards that system of having a continuous living root on the field, to me, that's going to take up nitrogen. If it's available, if we got a crop that's there, it's going to scavenge that nitrogen. So then we get into more of a scenario of nutrient cycling, and the whole nitrogen dynamics in the soil becomes much, much different. Going back to that question, does it work in the arid West? So I'm active with a bunch of crop consultants from all over the country, and there was a lot of skepticism on that in the arid West. But as the years went by, I'm hearing more and more from those folks that they're also finding systems with cover crops that work.
That's great. We actually have a question for you, Steve, coming in from the Slack. And the person asks if you could please address the issue relating to increasing precipitation in the Wisconsin-Minnesota area and how that's exacerbating the nitrogen leaching problem.
Yeah, so as you saw on some of those maps, a lot of Wisconsin is tile drained. The area that I work in is highly tile drained. A lot of Minnesota also, and we have been experiencing heavy rain events. Instead of getting 1.5 inches, we'll get sometimes 3.5 inches of rain in an event. The year 2019 was our normal precip might have been 35 inches. That year we had more like 45 inches. So just inundating. And as we all know, our nitrate's going to go where the water goes, and definitely a problem. So farmers are realizing that, farmers are experiencing that. Because of the dairy we have, we have heavy soils. We put out most of our manure traditionally in fall, which is not a great thing environmentally. And when we have those kind of conditions, we experience denitrification, and we see yellow corn the next year. We end up putting on more nitrogen. So it is definitely a challenge that we recognize we have to solve this or get much better at it. But we have challenges.
Stuff. Robin, I think that you have your hand raised. I'd like to chime in. And I'm sure you may actually have some thoughts too about some of the social science aspects that Carl's been raising.
Yeah, and actually, I think my question might have just turned into a comment because it was kind of addressed by that previous question. So I was going to raise the issue of the changing climate. So I feel like we've talked about these tools in the context of a static world, and the reality that is not the world we're living in. So I was just hoping you could both comment on how would we prioritize our focus given the reality of the changing climate, which is wetter for most of this land area. And does that mean, in my opinion, that would mean more of a focus on the edge of field water management piece, because we'll never get there without that. And not to downplay the soil health component, but recognizing that our kind of immediate challenge is water management. So I was just hoping you could reflect on that a bit.
Yeah, that's definitely the big issue, right? Climate change. And certainly the view is that there's going to be more rain, but the flip side of that is that, you know, you also have other extremes, and you may have more droughts. My own research, we've shown that, you know, when we're looking at these wetlands, they do a wonderful job of creating a natural denitrifying community. And then what happened? Well, we had a modest drought, and it dried the wetland out, and it completely knocked out the microbial community for a year. And, you know, that was completely unexpected to us. We had developed this wonderful, rich organic mud in the wetland. It took a few years to create that. And once it became oxidized, as it was exposed to oxygen, it just, all of the labile organic matter was gone in weeks. It was really astonishing how quickly that occurred. And so I think that really speaks to understanding, you know, or understanding that in a dynamic world, we have to build resilient systems that are able to, you know, handle large changes. We cannot design these things and go into it thinking that the conditions that we have right now are just going to be the same as you know, they are going forward. So I fully agree that climate change and the wider variation in climatic conditions we're going to have to be taken into account, and systems have to be designed to be resilient, to have a lot of buffering capacity to handle both increased precipitation and also increased prevalence of drought conditions.
Did you have any thoughts that you wanted to add? No pressure.
Yes, yeah, I would like to add to that. So the dairy farms I work on, several of them are permitted. We can't discharge to waters of the state. So even things like feed area storage, if there's rainfall that falls there, a lot of times that rainfall has to be collected and stored. And the temptation on a lot of farms is to put that into manure storage, which I personally feel is a real bad idea. It's taking relatively clean water and putting it with manure. So instead of that idea, what was mentioned there, these edge of the field storage of tile drain water, and we could also put something like this feed area runoff water into that, and then use it later in the season as irrigation water to recycle those nutrients and keep it from going into the stream. So I do think there's a lot of traction there, a lot of interest from dairy farms on that kind of thing.
Yeah. Thank you, Robin. We have another question coming in from Slack, and it's directed at Carl, but Steve, you may also have some thoughts here. And the question is, can we look at both nitrogen management and carbon sequestration in these farm level mitigation wetlands? I think it's actually springboards off of Robin's question nicely.
Yeah, so again, you know, I keep hitting on this, but looking at it from a systems approach, that if we, at our peril, we focus on one biogeochemical system and ignore the others, really. That's not the way to go about it. You know, these macronutrients, carbon, nitrogen, and phosphorus, need to be looked at the same time, really. You know, for example, globally with Haber-Bosch, we've completely changed the nitrogen to phosphorus ratios on a global basis. We're just beginning to scratch the surface of understanding how that is impacting ecosystems from the microbial to continental scales. And in the same way, what are we doing at a small scale on a farm? Okay, so we have nitrate, you know, quite soluble in water and being released. And then we have phosphorus that we're adding, and also, you know, some of it gets released as well. Some of it gets bound. It has a different biogeochemical cycle. Well, we have Haber-Bosch. We have means of creating more nitrogen from the 79% of the atmosphere that is nitrogen. But once we take concentrated phosphorus in mines in Morocco, let's say, ship them all over the world, and then dump them ultimately into the oceans, where we're never going to be able to get them back economically in a cost feasible manner, we really need to be thinking about that. And so I would argue that an integrated management that looks at not just nitrogen, but phosphorus as well, and then carbon, looking at it from a system standpoint, perhaps we can create systems that don't go through so much carbon in such a, that's why we keep having to add carbon again and again and again. But if we can make the carbon more resilient, perhaps looking at ways to keep it there for and in a less bioreactive form in farmers' fields, I think those go a long way towards looking at this from an integrated standpoint.
Yeah. Steve?
Yeah, I really think we've got a great opportunity here. This iteration of carbon credits, farmers are buying into. They're excited about it. They can see the benefits, not only from soil health, they can see that they're going to get paid. It's not just a tax system. And with that, I can see farms are entering a new, what I call a golden age of land stewardship. They realize the soil health thing. They realize cover crops, no-till, and I can get paid for this. And then to fold it in with carbon credits, if I understand the situation correctly, so nitrous oxides that are, a byproduct of denitrification sometimes, are 298 times more effective than a unit of carbon. So if we go about this the right way, we don't demonize agriculture, or especially animal agriculture, for generating nitrous oxides. If we engage them through this iteration of carbon credits, that if we manage nitrogen differently and we can reduce nitrous oxides, your carbon credit on your land goes way up. When we talk about carbon sequestration, that's a long-term deal. That's, they're talking 20-year commitments or 100-year commitments. If we're talking practices that reduce nitrous oxide or nitrous oxides, that's a year-to-year thing. That if we can show that we are doing this and reduced emissions and reduced nitrogen use, theoretically, we should have a really big carbon credit for that would go to a farm. So the other side of that double-edged sword, though, is questions like, so what does edge of field, what does saturated buffer do to nitrous oxide emissions? Is that neutral? Does that create a bunch of nitrous oxides? We need to know those things also in the big picture. Like Carl was saying, it's a systems approach. We need to know, if we do this, what happens to that in the whole big picture. But I really think if we go about it right and engage agriculture correctly, that we can use this carbon credit thing to our advantage for nitrogen management in a big way.
That's great. I feel like in your remarks there, you both identified a knowledge gap that we can maybe come back to in the third discussion session, as well as some issues that are relevant to the next session about behavioral changes and tools. Okay, I see that we have a question from Richard Wilkins.
Thank you. And I don't know if this is the appropriate time, maybe after the next session would have been more appropriate, but here's I heard it said that there's no magic bullet. in order to make headway with this issue, there needs to be multiple approaches and multiple cures. So my question is there any potential possibility for creating an opportunity for farmers to turn some of the cover cropping, some of the types of crops that they could grow in between their cash crops and help them to actually earn revenue and cash from that? And I mean, I can throw a few out there. Is certainly if consumers would return back to previous levels of per capita consumption of milk, dairy products, then that would allow more dairy farmers to return to grass-based or more forage-based rations rather than total confinement dairies. If we could find a way to export more barley and wheat, winter barley, winter wheat, those would be some crops where we could return back to where we were previously with the levels of acreage of those crops that were grown in the United States. And then, certainly beef, if we would be able to get better access, better trade agreements into overseas marketplaces where consumers are in other countries, emerging economies are demanding more animal protein. So just introducing that, what's the panelists feel about that possibility?
Well, I would say I'm pretty plugged into the demonstration farm networks and the cover crops and no-till and those kinds of things. And it's common to read about, a farmer, whether it's Indiana, Iowa, in an area like Iowa that doesn't traditionally raise much winter wheat. But as farmers are getting into cover crops and soil health, it is common for them to start incorporating a small grain into their rotation, not just corn and soybeans. So I think things, there's signs of things moving in that direction.
Yeah, I guess I'm going to back up a second. So when I first started working on these treatment wetlands, we would have meetings, public meetings in rural Illinois, and I was really struck by something. And that is how popular these are amongst groups that I never expected to be seeing together and agreeing on things. We have farmers who are liking it, particularly if there could be government subsidies to construct wetlands. And then you had environmentalists who liked it because of ecosystem services. And then you had hunting groups and other conservation-minded folks who like Pheasants Forever. These are systems that should not be viewed as a cost, okay? Even though we've been arguing that, you can set up some of these or should be targeting some of these conservation measures for more marginal land, less profitable land, they're providing services that are not well quantified economically, but I can bet you that they're quite undervalued based upon, the services that they provide. And I think that farmers can be thinking more broadly about the business that they are in. They can be producing things besides food. They can be producing ecological services. One example, one of our wetlands, the farmer was in an experimental program to provide pollinator habitat. Turns out that those pollinator plants were pretty expensive. I was really surprised. But, these are needed ecosystem services, and it went hand in hand, and it was producing, all of this rich pollinator habitat, which is really used by agriculture as well as a lot of other ecosystem or to provide a lot of other ecosystem services. So think more broadly, I guess, beyond just food products, but other types of things that can be done while achieving the goal of, soil stabilization and, cover crops, et cetera, protecting riparian buffers, et cetera. But looking at not just that one function, but other functions that are being provided by it. And maybe that can be monetized or supported in some way when we look at it more from a systems approach.
Yeah, that's great. Thank you, Carl. I think we'll take just one more question from Eric Davidson, and then we'll move on to our second discussion session, which we've already started to head into with this conversation. So,
yeah, thanks. And this question might be part of that too. It's a question for Steve mainly, but since you were talking about carbon credits, as I understand it, the Biden administration is very seriously considering this program that they call carbon banks. The details remain to be seen, but basically it's paying farmers to adopt some forms of what they call regenerative agriculture, which likely be cover crops and maybe some other things. Of course, I have concerns about the permanence of the carbon sequestration, but nevertheless, I'm wondering if there's something that we as scientists might be able to advise to make sure that for whatever carbon benefit there is, if that policy is adopted, that there's a nitrogen co-benefit. Certainly, even if the carbon sequestration isn't permanent, because farmers, even using no-till, tend to till once in a while, even if it isn't permanent, it is likely to improve soil health in a lot of different ways, and including having sinks for nitrogen or temporary storage for nitrogen. But are there some tweaks that would be important to articulate right now as to how a carbon bank system could also have nitrogen co-benefits?
Yeah, and I would just kind of reflect Carl's comments. I think a farmer looks at this as, okay, I can manage my land. I've got this critical habitat here that I could get some kind of benefit to plant a pollinator strip or whatever. Maybe there's an endangered species. I can manage that land. If I can get some kind of benefit, if some major corporation is willing to buy credits from me, but like Carl's getting at, I don't think they necessarily need to be separate. Yes, they're separate, but they go together, right? Managing the land for soil health has nitrogen benefits, also phosphorus, also carbon, and ecological, endangered species. It all goes together. So I think we need to think about those things, like Carl's saying, in a systems approach, and talk about them together. I think that makes sense to a farmer.
Great.
Thank you.
Thank you. And Carl, did you have anything you wanted to add to that?
I'm fine with that. Yeah, I think that's, yeah, I mean, it ultimately, I guess my view is let's get one market up and running and successful. But as the question got at, yeah, we can think ahead, but I'm hopeful we can get one market, up and running. And then if that's successful, I can see that opening and lessening that activation energy to create other types of markets that will be synergistically beneficial.
Yeah, that's great. Well, thank you both, Carl and Steve, for being our fearless discussants during this session. And I hope that you'll remain on. And I think some of the ideas that you guys both raised and that were discussed amongst others will probably come up in the next 2 discussion sessions as well. So thank you both.
Absolutely. Happy to be here.
All right. Can we get up the second discussion session slides, please? Thank you, Sarah. Great. So at this point, we're going to switch a little bit into a second solution pathway that is really focused on behavioral tools, as we're referring to them in shorthand. I'm not going to walk through these again because I did that when in my opening presentation, but they're here as a point of reference To kick off our discussion here, we have Steve Hoffman. Oh, I'm sorry, Thomas Hertel from Purdue University. He is a distinguished professor of agricultural economics, and his research and teaching focuses on international trade and food and environmental security, including using targeted policies to manage nitrogen in U.S. agriculture. Can you move to the next slide, please? So we've given Tom the same set of questions to sort of think through, but now kind of in the behavioral context, behavioral tool context. So Tom, please take it away, and then we'll open up for discussion.
Okay, thanks, Jennifer. Thanks, Jennifer. Yeah, before opening my comments, I just wanted to thank Kathy Kling, the entire organizing committee, and the National Academy staff for putting together a really informative series of workshops. I'm actually very new to this area and very much a consumer of the knowledge being delivered. It was great to have the top people in the country working on these challenges gathered together. Very efficient way for me to get up to speed. I'll respond to the discussion prompts that were provided, and I will bring somewhat of an outsider perspective. As was noted, I've worked a lot on international trade. I take a kind of a global perspective to these issues, and you'll see that in my comments. I hope that my economist colleagues in the workshop, Kathy, Leah, Steve, and others will chime in and participate actively in the discussion. That'd be valuable. So first question is, what's missing from the list? Well, for me, coming at kind of every problem from a global economy trade perspective, I'm seeing these interventions, these behavioral interventions, as largely being local level and missing the broader market and policy context in which, which is increasingly global. So just as Carl was arguing in the previous session for a systems approach to biogeochemical processes, I think we need a systems approach to thinking about the nitrogen problem, in this case, a global economic systems approach. So we need to understand how other government programs like the Renewable Fuel Standard, crop insurance, other government payments, trade policies, how all of these affect crop choice, cropland extent, incentive to intensify. I mean, without that, I don't think that it's not just climate change that's driving the future. In fact, climate change is less important probably than population growth in sub-Saharan Africa or income growth in Asia in terms of driving this system in the future. So it's not just the biophysical system, we need to think about the economic system. We can tweak the nitrate mitigation policies all we want, but if the fundamental economic drivers of this system are dictating more corn production, more intensification, I don't think these tools will have much of an impact. And our current projections, we've done projections to mid-century under business as usual economic growth assumptions that suggest the problem is going to get worse, not better under current practices. So don't mean to be too gloomy, but I just mean I want you to be thinking about this in the context of the global economy. Also, to piggyback on the remarks that I thought the previous panel was great. Carl was highlighting, for example, the need to shift our thinking about what agriculture produces. That agriculture doesn't produce just food; it produces ecosystem services or disservices, as the case may be. And I think we could learn something from Europe. They've shifted over the last couple of decades from a system of dramatic price supports and big payments to producers for just to produce more food, to now most of the payments being directly linked to the delivery of ecosystem services. Something more along these lines could be very attractive in the US. Steve Hoffman was echoing this point as well. Given the amount of money we put into agriculture in the last couple of years, and this is clearly unlikely to be politically or fiscally sustainable in the future, you could buy an awful lot of ecosystem services for $20 or $30 billion a year. And there could be significant public support for this. So I'm just echoing the way the last session ended up on this
note of agriculture shifting to a supplier of ecosystem services could be very satisfying for family farms who really care about stewardship to be paid for what they're providing in terms of benefits. Second question was, which options would you spend the limited resources on? And my first point was just one that was also echoed in the previous session, and that is, there's no one silver bullet. There never is to these environmental and economic problems. You have to take a portfolio approach and use a variety of mechanisms. But I do want to return to the presentation in this workshop a couple of weeks ago by my Purdue colleague, Jane Frankenberger. She's devoted her career to tackling this problem in this part of the country. And she and her team have developed this very clear set of guidelines, top 10 solutions for reducing nitrogen and phosphorus pollution from agriculture. These have been communicated widely, effectively. They have animated videos. They've met with farmers. They've met with agribusiness. They're really out there engaging. But I think if you ask Jane, and she indicated this at the end of her talk, adoption rates are low, and these are going to go nowhere without some additional incentives, either in the form of payments or regulation. It's just not going to happen. The numbers don't add up. Yeah, I think that's the hard truth. So this session is very important. I'm not necessarily the one to speak to all of the solutions in a behavioral context, but I'll run through them briefly. In the order they were presented to me, I'm not sure it's the same order as the slide, but they're same order, the order presented to me yesterday when I agreed to do this. So better targeting of funds, yes, by all means. My colleague at Purdue, Jing Liu, who's on this workshop call right now, has estimated recently that 50% of the nitrate leaching mitigation, using a variety of different solutions here, for each of those, 90% of the mitigation tends to come from about 10% of the grid cells in this Mississippi basin. So targeting makes an awful lot of sense. And this is an area where devoting the money to specific leaky grid cells will have maximum effect. Farmer collaboration models, I think it's great to foster collaboration. It's fantastic to get farmers working together on things, these kinds of problems, but it's not going to overcome the incentive problem if you just have the farmers in the room. You really need the impacted communities in the room. You need the wastewater treatment plants that are trying to clean this up as well. In the room, you need to encompass all of both the suppliers and the demandeurs of this. That takes us into the water quality trading question. In addition, instead of having them all in the same room, you can provide them with a market in which those for whom it's expensive to clean up this pollution can pay agriculture, where it tends to be a very cheap mitigation option, pay agriculture to do it. The problem is there just aren't so many point sources in the Midwest. It's just not viable. There's a huge amount of non-point source pollution, and not so many urban areas that might be willing to make those payments. Supply chain leveraging, another great idea and has value. Certainly to the extent consumers are informed about these things, there's a small but significant percentage of consumers who will pay more, or who will be more loyal to a product or a company, a corporation, if they see them addressing this problem and it gets communicated through the supply chain. But it's always going to be just a subset. This is being tried in many other areas, working that supply chain back, and it has some effect, but it's not going to solve the problem for us. The auction markets, I don't know much about that. I enjoyed listening to Leah talk about that. I hope she'll elaborate on that in the discussion section. Shifting from farm scale to watershed scale conservation problems, well, yeah, it's obvious that if the environmental problem is at the scale of the watershed, you need to be working at that level. You need to be making your decisions at that level. thinking about it just from the point of view of an individual farm without considering the other farms, the natural areas, the topography and the geography of that watershed, it's not going to be effective. So that's all obviously a very positive thing. The last question I was asked was how to operationalize these tools. And I was hoping Chris Clark from EPA would chime in on that, but I guess he wasn't available. But perhaps Kathy and others with experiences in this area from the economic perspective could comment on this. But yeah, that's what I have. Back to you, Jennifer.
Thank you so much. I think you've given us a lot of good fodder to kick off this part of the workshop. One thing that I was actually, as the slides come down, one thing that I was actually interested in hearing more about, Dr. Hurtel, that you've just raised is this shift in what's happened in Europe in terms of paying farmers for ecosystem services. Can you sort of elaborate a little bit on what that transition looked like? If you feel that it's been successful?
Well, I think the deeper you dig into these things, the more problems you see. I was, a couple months ago, I was feeling super enthusiastic about the European experience, and then I started reading more of the careful evaluations, and of course, they fall prey to many of the problems that you find in U.S. conservation programs, CRP and others. But they have become more focused. So they went from decoupling their payments, paying maybe by the hectare, to now actually really targeting those. They have now currently, since 2013, 5% of the farmer's land needs to be devoted to ecological focus areas. So we heard about pollinators, we heard about other things, those would all fall in that category. I mean, those who study this in detail, for example, in Germany, find that they're, often the programs are abused. There's a loophole and they'll put something in there that's not particularly environmentally friendly. It's hard to implement these programs, and that's one thing to learn from them. But the focus has clearly shifted more towards payments for ecosystem services. There probably are others in the workshop who know much more about these policies, so I'll defer to them.
Yeah, and I was also wondering, and maybe this is something to ask other participants, is whether or not there's been opportunity yet to sort of quantify the impact of that transition in terms of either environmental benefits or monetary benefits. I don't know if it's been around long enough to really do that, but it's another question.
Yeah. I was reading a paper just the other day on this, that it was prospective. There may not be enough data yet to fully look back in an observational sense, but they were doing modeling of these things at fairly fine spatial scale, and they were finding modest benefits. I think it's going to take them time to tweak their programs to have full effect, but I think in the long run, that's what the U.S. citizens are going to be willing to pay for. They're not going to be willing to just continue to pay. When we hit the next budget crisis, which we will, they're not going to be willing to just transfer funds to farmers. They're going to want to see something in return, and there's consumers are more and more concerned about the environment, and we saw how important it is from a health point of view, and probably underappreciated in the rural areas, how dangerous the groundwater pollution is. But I think there's going to be more demand for these services and less willingness to spend the money in other ways. It's a natural shift. It's got to happen.
Yeah. Kathy, you have your hand raised.
Yeah, hey, Tom, lots of great comments and fodder. Thanks a lot for taking the time to do that. So I wanted to follow up on a couple of the points that you made. The hard reality here is that when you have externality being generated, when you have pollution coming from production of something, it's creating costs on other people. And that's the discussion we had about nitrates in water pollution is in water, drinking water. It's the costs that are imposed downstream to community service systems. The economic solution to that is to have the polluters bear the cost of addressing that. That has an extremely nice feature in that if everybody in the system is required to bear that cost, markets work and prices go up. Consumers are forced to pay, as they should, for the full costs of those systems. We don't do that in agriculture. There has been the Clean Water Act exempts, except for animal feeding operations. We heard a little bit about dairy. Row crop agriculture, the 300 million acres corn, bean, and wheat that we have in this country, the 65 million acres of tile drain systems that Jane Frankenberger's work has been so good. And the simple truth is you can't change a fundamental economic incentive by wishing it wasn't that way. So yes, we could decide to pay farmers to reduce nitrate, to put things on their land. Unfortunately, that would cost a ginormous amount of money. Number one, the kinds of top 10 program, the tools that Jane has identified, things like bioreactors, we're talking $10,000 a bioreactor that treats about 30 acres. Okay, we got 65 million acres of tile drained land, something like that. Again, it's just an enormous amount, and frankly, it's strange to pay people not to pollute. So I've been saying these things, and it makes me not very liked. But to me, it's kind of like, climate change. We wish it weren't happening. We wish we could pretend that the system didn't work like it does, but it is how the system works. So in that case, what can we do? Well, we could regulate, which is what we do with every other pollution sector. If that's off the table, then we really don't have a way to do this at scale unless our brilliant scientists come up with almost free ways to keep nitrogen on the land. So having just shared my little diatribe with you, would you, one final bit of my diatribe is, farmers, of course, like all of us say, oh, I'd love to be paid to do something more. I'd like to be paid to plant the marigolds I love to plant in my front yard because, but they're only going to get paid what it actually costs them. They aren't going to make profits on it if we're doing this well. So whether they even really understand that if there was these payment service, these markets, they wouldn't make any money on it. It would just cover pretty much the cost of doing it, which is another part of the problem. Anyway, I'll stop.
Tom, I'm gonna invoke phone a friend for you now, so you're not in the hot seat by yourself throughout this. So I think Leah Palm-Forster and Steve Wallander might also have some thoughts that they'd like to contribute. But great diatribe, Kathy. And Leah and Steve, if you would turn on your cameras, that would be great.
Sure, I'm here and my cameras. Yep, there we go. So Kathy, that's difficult to follow. I'm with you. It's a difficult, when I try to think about what I could say to add to that, though, I struggle to think about what comes next. And I think it comes to your last point. If regulation is off the table, right, and we're working within the constructs that we're in which it's a pay for ecosystem services system, maybe the question then becomes, how can we do that in the most optimal way or the best way that we can structure that system? And so maybe I will make a few comments from that angle. It doesn't take away from anything that you just said in the beginning, but then it kind of brings us to the point of like, okay, here's where we are. So maybe how could we move forward? And I wish I had the perfect answer. I would be very valuable to this panel if I did, obviously. But perhaps a few thoughts. I mean, one that's already been emphasized so many times is let's continue pushing, thinking about how we make these programs scale better. Because although that is said over and over in forums like this, I feel like often when we move out into the programs, they're often very piecemeal, run out of, a particular county soil and water conservation district, which are so valuable. But if we're limiting to the confines of a county, then we're missing the watershed scale at which actions are creating outcomes, right, for our water quality. So if perhaps there are ways to think about bridging that, Kathy, last week you asked me about group incentives that may exist. And it seemed that the response after your question from the great farmer panel that we had last week was that perhaps there are some opportunities to get more of that collaboration. And I think to kind of the cooperative system, are there ways to tap into that with making, helping to address this bandwidth problem? Everyone has limited bandwidth. So are there ways that people can come together collectively and try to reduce the barriers, right? Reduce the barriers, make it easier to either, A, enroll in programs, B, access equipment, access inputs that are so critical for adopting many of these practices, and provide assistance and kind of technical support capacities to help get some of these programs on the ground. So in addition to, reducing barriers, that would also hopefully help us move forward in creating more of this kind of social norm with this collective action that we would be engendering with this system. So that's something that I hope more research focuses on, because we've been so focused on the individual. And I know that there's a lot of work kind of pushing this more collective approach, and it only makes sense. If we have a landscape problem, we need landscape solutions. So I'll pause there for a moment. I'm sure my other colleagues have plenty of other things to bring to the conversation.
Tom, I didn't know if you want to jump in or no, you're okay. So
I'm enjoying I'm listening.
Steve, your thoughts, and it's good that you turned on your camera, because we actually have a question addressed to you within this context, which is about, in addition to whatever you'd like to add, what if federal programs can be adjusted so that they're more targeted at the watershed level, perhaps relative to the farm level. So Bibi, when you share your thoughts, you can tackle that question too.
Okay, sure. I could add a little bit of that to my thoughts. I guess we've got sort of the monopoly of economists here, even though we know there are costs to monopolies, right? But I think the stuff that Tom brought up about the EU shifts are really interesting. I was thinking of them in the sort of US historical context. You could argue that over the last 30 or 40 years, we've actually had a similar shift in our policies. The Conservation Reserve Program was a decoupling of the old set-aside programs that were targeted as commodity support and saying it really needs to be focused on environmental outcomes. The Conservation Compliance Program is linked to the remaining commodity payments and now the crop insurance payments. I think in terms of our discussion here, the key thing about that sort of decoupling and linking to environmental outcomes in the US context is that it has been very, very heavily focused on erodibility and highly erodible lands. And so if we were thinking about using those levers and refocusing them on, say, nitrogen hotspots or areas with drinking water concern or something like that, and we assume we've got fixed budgets, we'd be thinking about what the trade-offs are, right? We'd be thinking about pulling back in some of the focus the targeting on highly erodible areas and to some of these other high nitrogen areas. And so there would be trade-offs in public goods. And I guess that sort of public goods aspect of it is the other way I think about this. We talk about the ecosystem services of nitrogen abatement. And from the sort of environmental economist perspective, right, the key thing about those ecosystem services is that they are public goods, right? You can't get adequate provision of them in a public market, and you basically have, you know, three options. You have the taxpayers can drive it through their political representatives, and you can have what we have now with sort of the USDA programs, and you can provide the goods through public spending. You can use regulation indirectly and have the water quality trading, but ultimately that is the demand in those markets is not driven by the ecosystem service per se. It's driven by the desire for regulatory avoidance by the regulated entities. And so the regulation is the driver of demand there. Or the third thing, which we talked about a little bit, was the sustainable sourcing, and it can be sometimes consumer driven, and the corporations can come in and the supply chain can come in. You know, I think the jury is still out on that as to whether or not that would ever scale up. Some of the discussions we had earlier were that there is a lot of growing effort at sustainable sourcing, but not a lot of money on the table yet. So, you know, I think going forward, we're probably going to have advances on all three fronts for trying to provide these public goods and this nitrogen abatement. And the interesting question will be how these efforts interact. On the watershed scale question, I think we have some experience of that within existing programs. Also, there's more and more state-focused, state-driven programs that are sort of watershed-focused. And I think there's a good argument to be made that you don't start to see effects in some areas until you reach a critical mass of investment in cover crops or drainage management or other things, that if you go down to sort of a Huck 8, you really need to sort of get a lot of conservation on the ground to do that. So then the question becomes, with the limited budget, we're going to have to focus on some watersheds and pull away from some other watersheds. And is that a desirable outcome? And it raises equity concerns if you're financing it through, you know, all taxpayers. So.
Yeah. I see that Craig has raised his hand.
Hi, folks. Nice to see you all again. Just three quick points following up on some of Tom's comments. One is, thank you for raising the issues around the structure of our current crop insurance and farm subsidy programs. I mean, I've been working on voluntary conservation programs for 40 years now, and those, whatever incentives we can create through those voluntary programs have been effectively overwhelmed by the incentives created by the way we subsidize farms and the way the crop insurance program works. So I think that issue has to be on the table for this workshop. The second thing I'd say is, Tom, you also mentioned, I mean, one of the advantages here is that geographically and ecologically, there's a lot of potential for targeting intervention, especially in the groundwater nitrate systems, where the combination of vulnerability to leaching with land use is a very knowable thing. In fact, we know with some great degree of precision, precisely where the fields are that where intervention is needed. We, as we've argued for years, can target voluntary programs that way, but we can also target regulations that way. So I don't think regulation is off the table at all. I mean, maybe it is conceptually in the workshop, but Nebraska, Minnesota, Wisconsin, I mean, other states are actively moving ahead with what I would call precision regulation and coming up with regulatory approaches that are highly targeted and, you know, aren't the sort of broad scale, every farmer needs a permit. So I would certainly think that should be on the table. And then the final point to me, which is sort of drives all of my thinking about what are the appropriate policy interventions. It's how much time do we have? You know, if we think we have 10 years to get on top of the nitrogen problem from a human health perspective, that leads me to a certain set of recommendations. If we think we have 50 years to get on top of the nitrogen health issue, and I think somehow we need to incorporate what our sense of urgency is here. And that sense of urgency may be different. If you're a small town in rural Minnesota, which is looking at spending millions of dollars to install a nitrate treatment facility, then the sense of urgency may be very different than if we're thinking about other issues. So I don't know how, personally, I don't know how to make a choice about a policy intervention option without some clear understanding about what's our time frame when this problem needs to be fixed.
Thanks, Craig. And you, I see that Richard Wilkins and Steve Hoffman have their hands up. And so I actually think it could be useful to bring them into this conversation now as you all think about Craig's comments and respond.
I'd defer to Richard if you're ready to talk for now.
Yes, thank you. I want to make a comment about the suggestion of interventory regulations and as it relates to crop insurance. Now, I'm not a degreed behavioral scientist, but let me make an observation of how I believe my farmer colleagues would react if additional conservation compliance requirements were imposed in order to qualify for the existing levels of federal crop insurance subsidy. They would react very badly, and I think that most political scientists already recognize that we have a political problem in our nation now with a rural-urban divide and problems with levels of trust between those different constituencies. So I would discourage any direction towards trying to impose additional conservation compliance requirements. Come up with, if that is a way to get desired behavior, then offer say an additional discount on your crop insurance if you will adopt a particular environmental friendly adaptation. Don't say we're not going to give you anything else, but in order to keep what you've got to do more.
Thanks, Richard. That's actually that's some helpful insight into the mind frame of or the mindset of farmers and how some of these ideas may play out in reality. I also want to acknowledge the fact that I believe that you're in a tractor, and that is awesome. Steve.
Yeah, I just wanted to build on that idea of the carbon credits. And I heard a session this week from a fellow from Canada. I think they're a little bit ahead of us on carbon crediting. And what I did not understand before that session is that the methane and the nitrous oxide emissions crediting is the same system. So any reductions in these other greenhouse gases are going to be paid as carbon credits. It's all the same system. And so in that sense, I think if we can be proactive and make sure that as this carbon credit system evolves, that it addresses nitrous oxides, we're going to, in effect, really promote better nitrogen use. And the other thing that comes along with this whole idea is that farmers can't get paid for installing systems if they're required to by law for some regulation. So if we get too heavy-handed or too involved on the regulatory side, it removes the possibility from farmers receiving a carbon credit from doing practices. So I think it's just one thing we need to keep in mind.
Yep, going back to the interconnectedness of various interventions. I think Richard has his hand up, but that may be a leftover from before. We're almost at the end of time for this session, and I think that there is a question coming in, though, from Slack that's directed at Tom. And the question is, I really appreciate your call for system approaches and your note about the missing of large socioeconomic drivers on the behavioral tool list. I wonder what you think of the potential influences of a more favorable biofuel policy, maybe also changes in the US-China trade relationship, on the agricultural production as well as the end uses in the Midwest, whether and how we can take these changes as opportunities to influence the nitrogen management dynamic on the farm.
Well,
It's a big question.
Anything that encourages more corn encourages more nitrogen. That's pretty clear. Potentially more intensification. So, that's a challenge. I think from the renewable fuel point of view, as long as the oil prices stay low, and they're expected to stay low for quite some time, the only way you're going to get demand for biofuels is through government mandates. And that's obviously not popular with the oil companies who are struggling. And, I just don't think you're going to get more action on the biofuel front politically or economically. It's just not there. And on the trade front, independently of the nitrogen problem, and as I said, more exports means more production means more nitrogen, and just exacerbates the challenge. And that's what I was emphasizing before. We're talking about a future of climate change. Well, if that future also includes more open trade and more exports, that presents an even greater challenge probably than the climate change, at least to mid-century. On the trade front, though, just stepping back and making a more general point, we've done the calculation how much of the increase in US crop output to mid-century is being driven by domestic forces, domestic demand, population, income, et cetera, by foreign sources. It's 4 or 5 times as much overseas. So if we close off this economy, basically agriculture is dead in the water. There's not going to be much happening. So this kind of trade war, raising the barriers, raising tariffs, this is very bad for agriculture, just from a general observation, independent of what we're talking about here today. From a market point of view, global economic point of view, it's a disaster for agriculture. So even if you get payments for a time to compensate for the trade war, they're not going to be sustainable. And so that's just an aside.
Great. Thank you so much for being our discussant for this session. I hope that you'll be able to stay on and help us think through filling knowledge gaps, which is our last discussion for today. And if I could have the slide up. All right, thank you so much. Okay, so to close us out, or to close out the discussion portion of the workshop, we are going to be having conversation around knowledge gaps. In my opening remarks, I had up this slide and had presented these 3 specific examples that had been identified over the course of the workshop series as critical knowledge gaps. And so to help kick us off in this session, we are joined by Bonnie Keeler at the University of Minnesota. She's an assistant professor there in the School of Public Affairs, and she works at the intersection of sustainability science and environmental economics, and has a particular focus and expertise in water management and policy. And we'll also have Ken Caspin, who who's already made a presence in this workshop today, and he is Emeritus Professor of Agronomy at the University of Nebraska and is an agricultural consultant. He's had a very seasoned career in research and has largely been focused on ensuring local to global food security while conserving natural resources and protecting the environment. So with that, Bonnie, please take it away. Thanks.
Yeah, great. Thanks. It's really great to be part of this conversation. I've been tracking the workshops over the weeks and I've learned a ton. So my charge was to talk about what are 3 knowledge gaps related to estimating the social costs of nitrogen pollution. So I'll give you my 3, and then I'm curious what other people would like to add to this list. But number 1, I think, is getting a better handle on the spatial heterogeneity of nitrogen damages. And, we heard about the epidemiological research that's showing we have differential health impacts in different communities, and that there are hotspots of those impacts across the US, depending on where you get your water from and how much you consume. Personally, as a well owner with elevated nitrate living in an agricultural watershed, I am also interested in the damage costs associated with pollutants that are co-located with nitrates. So if I've got nitrate in my well, it means I probably also have other kinds of agricultural contaminants, pesticides, herbicides, and those contaminants of emerging concern that we don't even really know how to monitor, I think, are also a concern. And nitrogen's always going to be a proxy for those. So there could be a lot more work really trying to understand which communities are at risk and expanding our epidemiological knowledge about those risks by subpopulation. There's a whole other set of damages that we just don't have a very good handle on. And so economists haven't been able to get us good answers on like the damage costs associated with Gulf hypoxia, for example, with harmful algal blooms, with eutrophication across its many forms and in different places. So I think there's more hydrologic and biophysical science that can really help us build better models that allow us to understand and trace those damage costs across space through different constituents. And then the last part of that spatial heterogeneity, I think, is getting a better handle on exposure. So that means we need information on where people live, where they recreate, where they drink, and their adoption of avoidance behaviors that could protect their health, could protect their exposure to nitrate. And I think that's been mentioned. And then, of course, there's an environmental justice dimension here that was that Elena Austin mentioned in her talk, of being able to better characterize the distribution of damages associated with race or income or baseline health status, access to information, language barriers. Those are all kinds of infrastructure quality, all reasons why you might see differential impacts on different communities due to their exposure to nitrate in their drinking water. So that's number 1, is really just getting a better handle on the spatial heterogeneity of nitrogen damages. Number 2 that I'm interested in is understanding the variability in our preferences for nitrogen-related damages. And I think we need to do a lot more as economists about understanding what's specific and contextual about people's, for example, willingness to pay for changes in water quality, and what is sort of generalizable and static. And do we know how these dynamics change across time, how they change across populations, and what we could say potentially about future generations or future people's preferences for changes in nitrogen-related damages. And just a side note, I think, as someone who is working on a recent review of the economics in some of the Trump administration's economic analyses related to the Clean Water Act, I mean, we've got regulatory assessments that in some cases are based on one state of preference study, from the 1990s in one watershed in Western Kentucky. And then we're applying that study to a broad set of cases that are outside of that area. So we need more revealed preference approach studies. We need more stated preference approach studies. We need other kinds of valuation assessments, maybe that don't fall into that traditional market-based approach or non-market-based approach, but that are also illuminating what are the values and damages that people are most concerned about. Because nitrogen has a cascading set of costs across lots of different areas. And then I think part of that is really doing a better job of unpacking these competing potentially objectives of efficiency and equity in the way that we manage nitrogen. So when we aggregate damage costs up to a population or to a federal level, we're actually masking a lot of those different values, and some may be incommensurable. We don't want to necessarily lump in the value of losing a cultural resource to eutrophication with the changes in a wealthy property owner's lake clarity and how it affects their property values, right? Even though we can convert those both to dollars, we may actually want to keep those values in separate categories so that we can better understand the trade-offs embedded in the way that we're estimating social costs. So there's lots of ways to think about doing a better job at characterizing that equity dimension, whether it's through equity weights or a better distributional analysis. And I think the Biden administration has definitely signaled a willingness to think about those kinds of approaches in the way that we do regulatory analysis. So then the last thing that I think is a knowledge gap that I wanted to flag is really a question about value of information. So how do we know the value of better value information? So if we think that we need to improve these estimates of the social costs of nitrogen pollution, we've got some numbers right now. Are those numbers good enough? What, as we improve or invest resources in improving the research to get a better handle on those nitrogen costs, are those going to actually change decisions? Or is that a good investment of our time? Do we know if we further refine those costs versus spending research on other aims, how sensitive are the suite of policy interventions and the set of decisions that the end users of those values would be making to the different assumptions that we're making about refining our values for nitrogen damage costs? So I think I'm interested in just thought experiments about how these nitrogen costs would be integrated into specific decisions. And that could be at the farmer or producer level, at the state or federal level, in different conservation programs or in programs targeting consumers. So if we think about the whole set of regulatory tools, which of those regulatory tools really depend on a better understanding of the social costs of nitrogen pollution? Which ones do we sort of have enough information to just get a ballpark? Because all we really need to do is just raise awareness of the issue. And then where do we actually need to get very good and robust estimates over time that are spatially explicit because we need that information to actually make smart policy. So those are my three. I think looking at spatial heterogeneity, getting a better handle on preferences and how they vary across populations and across space, and then doing a careful value of information analysis as we're trying to invest in better understandings of the social costs of nitrogen.
That's great. Thank you, Bonnie. And also joining us as a discussant is Ken Katzman. Ken, welcome to the conversation in this session. Hi.
Hi, okay. So I guess first I'd like to say if we're leaning towards incentive-based approaches to address the end problem in ag, such as the greenhouse gas or carbon credit system for climate change, then the value of those credits are partly dependent upon the degree of certainty in quantifying the benefits. So for example, in the stock market, often equity prices are based somewhat on the price to earnings ratio. And companies that achieve consistent earnings growth are given much higher valuations in the market because their earnings are certain. So from that, I come to the knowledge gaps that we want, if we use incentives, we have to be sure their value is real and certain. So the knowledge gaps I see is the capability to estimate acceptable NLOS limits at the field level to meet environmental and health water quality standards. They have to be robust, low-cost metrics that can give an idea of field scale NLOSs, so that farmers and supporting agricultural industries can innovate to reach them across the wide range of soils and climates and cropping systems that comprise our food system. These metrics must be low cost, reproducible, and reliable. They simplify on the far side of complexity. So I think that's a big gap right now. I think that when I look at the list of, for instance, on-farm practices in terms of managing crops and soil, I see some of them that are highly uncertain, certainly with regard to what Bonnie said about having this spatial, good spatial understanding of where things are happening. The second is, I would say, accurate prediction of NLOSs from specifically nitrate, leaching, and nitrous oxide. Again, at the field and subfield level. This is because farmers need a target. Also, the private sector needs targets, so that when they're testing new approaches, there are gold standard metrics for being able to estimate the benefits. And these, and I think what's very important now is that the research done to get these better predictions are done at field scale in production fields, not small scale research plots as we've done so much in the part. But these are enabled, we're enabled now to do actual on-farm research at relatively low cost, thanks to yield monitors, remote in-situ sensors that you've heard about, and more recent appropriate spatial frameworks that allow us that if we want to do a limited set of studies, because they're very expensive to conduct, where to do them to ensure that they have the greatest extrapolation domains for widest extrapolation possible. The third thing I think is not so much a knowledge gap as a data gap. And that is that there is a trend for less data available, less good quality data available to growers for seminal things like, for instance, weather. Although there's lots of weather data out there, the question is how good are those weather data for farmers to use to inform their decisions to more precisely manage crops and soils? And the answer is they're poor and getting poor because weather stations that provide the weather data that are used to make predictions on crop growth rates, phenological stages, soil moisture, etc., are based on fewer and fewer weather stations, believe it or not, that are located in farming regions that are not encumbered with built environments. Many of the weather stations that are in the national weather station grid have been covered up by expansion of cities, so they're no longer accurately giving us weather data for actual farm conditions. So the weather station in Lincoln, Nebraska is no longer in an area that's rural, it's in an area that's been urbanized. And this occurs throughout the Midwest. So we need a weather station system specifically designed to provide the best quality real-time weather, forecast weather, historical weather data for growers and their consultants and also private sector. So because precise management of resources depends on good quality weather data. Same goes for soils. And we have them, but they could be better and with very relatively little cost. So I think having publicly available, free, low-cost data on the factors that drive performance of nitrogen in agricultural systems is a public good that really needs investment over the short term. This could be done in the next two years, for instance, relatively low cost. The question is, what's the minimum number you need and where do you need them? And we have now spatial tools to answer that question very well. Finally, I want to say something about systems. We've heard the word systems several times, used in many ways. I want to use systems in the way of cropping systems or agricultural systems. I think in order for us to know what knowledge we need, partly it's what systems are we talking about? Are we talking about systems that need to be so dramatically changed because we've thrown up our hands and we've said, oh, the current corn, soybean, wheat systems, rice systems that comprise our major food supply are beyond repair, and thus the emphasis needs to be on new systems, new crops, alternative perennial crops, for instance, or in the time we have and given the trends and globalization of markets and food systems, do we focus on the systems that brought us here? And with that, I'll end and be interested in the discussion.
Thank you again. That was great. Lots of content from Bonnie and Ken for us to think about as a group. I have a question for both of you, and I will take facilitator discretion to ask them. Bonnie, I thought your commentary around the value of, or your thoughts around the value of information was really interesting and provocative. And I was wondering if you're aware of if there's been an assessment of what benefit there would be maybe from a regulatory or policy, in a regulatory or policy context of quantifying the cost of nitrogen. Like, does the regulatory context in which agricultural sits, how persuasive or impactful would that quantification be of the cost?
Yeah, I mean, that's sort of at the heart of what I'm really curious about. And I have some thoughts, but I bet there's others who would like to comment on that. I mean, I think you could envision, for those who are trying to invest in these new technologies that help to reduce nitrogen losses, having a sense of the scale of the benefits that they're providing would be useful, right? Like they're putting a lot of investment into this innovation with the hope that it's delivering benefits in the form of reduced nitrogen pollution. Having some sense of the size of magnitude of those benefits that they're creating would be useful, both in terms of their, I'm assuming, applications for funding to continue to work on those innovations, as well as decisions at the public sector of whether or not those should be investments that are good uses of public dollars, right? To continue expansion of that kind of R&D and then maybe pay for it to be implemented. We'd want to have some sense of the cost and benefit ratio of those kinds of interventions. And then, at the state and federal level, to decide if it's important to, bring new regulation, whether we're starting to think about non-point source pollution as something that should be regulated. We would like to have a sense of what's the additional benefit to society of being able to bring broader compliance with the Clean Water Act. Are we going to actually see big changes on the landscape, and what do we know about what the magnitude of those benefits might be relative to the costs? And I think we're actually starting to get a handle on this, and Kathy's done some of this back of the envelope accounting, and we've got values for all kinds of things, right? Like we could do this. The question is it going to change decisions? Is it actually going to be taken up into policy? And is it the key part of advancing a set of regulatory agendas, which have all kinds of political dimensions to them? It's not just whether they pass a cost benefit test. We also, I think it's important to recognize that in Minnesota, a lot of the work that I've done has actually not fed into benefit cost analysis, but it's really in terms of prioritization decisions. So, we have a fund, we have a couple of different funds, and those funds are devoted towards allocations of clean water resources to protect and improve water quality. And there's a commission that oversees how that fund is spent. And so the work that I've done helps to say, like, well, you have a limited pot of money, you're trying to get the best return on your investment. We don't actually even need to know what the damage cost of nitrogen is. We just sort of need to have a sense of the relative magnitudes of these different objectives, whether it's improving trout streams or reducing Gulf hypoxia or improving human health or drinking water quality or property values. And those can then inform the allocation of the investments that we have at the state level into different interventions that affect different watersheds and different beneficiaries. And then the last thing I'll say is that, I think it's useful to think about the whole suite of decision contexts that we're talking about here. And some of it is really just about raising awareness. Like, it doesn't really matter what the number is. We just want to draw more attention to the health impacts of nitrate. And so talking about that and getting a better job, doing a better job of evidencing those claims, whether it's in the form of narratives, stories, or if it's in the form of dollars. And then as you move more towards like, okay, we're actually going to do targeting, then you need a different set of values or a different sort of set of rigor around those values. They have to be spatially heterogeneous. And if you're going to then design an instrument like a payment for ecosystem services schemes, well, now you've also increased the level of sophistication and quality, I think, of evidence that you need to do that. And then at the far end, if you're thinking about litigation, are these claims about damages going to stand up in court? Well, then you might need a very sophisticated approach to estimate those damage costs. So having a sense of like where those damage values, where those social costs fit in across a variety of different decision contexts that vary in their complexity and audience and scale helps to determine where you should be spending your time in terms of producing science and economics that's like, I think, most fit to purpose and most influential in decision making.
Yeah, what would also be interesting to think about is the data that are available now to do those cost benefit impacts and to what extent it's sufficient for certain decision contexts and in which context, in which decision context there actually needs to be more data generated. It's not just a matter of like the computational execution of it, but the data are lacking to be able to get to derive the values that would be necessary in that particular decision context. And almost I can imagine a bit of it like a heat map a little bit.
That's a great idea.
Sort of think through that. I had a question for Ken. Ken, during your remarks, you had said something about farmers need targets. And as an environmental health and public health person, I often think of targets in the context of values like MCLs, and which were discussed earlier today, and thinking back, almost sort of calculating backward, which is like, what is your public health contamination target? Like what is sufficiently public health protective, and then working backward from there and determining what does that then mean in terms of nitrogen management. So I'd love to get your opinion of that. And then just, more generally, what else you may be thinking when you use the word target.
Well, I'm thinking of performance metrics that allow a grower to know if the things they're adopting are actually translating into reductions in the that make progress on the end problem. And so, because when we're talking about nitrogen, it's also cryptic, really, right? When we look at the relationship between fertilizer applied and nitrous oxide emissions, it's almost a cloud of points, really, from actual on-farm data. When we look at nitrate leaching versus N applied, there's trends, but it's pretty scattered. So the ability for an individual farmer to know if what they're doing is actually making a difference based on scientific evidence is not very good. Now, you can aggregate it and say, okay, we still have a significant relationship. The R squared value, that is the proportion of variance explained by the data, is less than 15%, but it's significant, highly significant. Well, to me, again, it gets to that price earnings ratio. It's so uncertain. The question to society is, how valuable is that to pay for with that degree of uncertainty? The other side of it is this. In my 50 years or more of working with progressive growers, when they are able to measure and see what it is they're trying to achieve, it's amazing what can be done. And so I think if farmers could know what their nitrogen fertilizer efficiency really was, Or how much nitrogen supply is their soil supplying, so that they know that they have to make up this much amount during the growing season. I have no question that growers could ease, and by the way, and the private sector needs these metrics. So we've on the Slack room, which is new to me, Tom Hebert talks about a product called Pivot Bio that's being promoted. It's a product that is using, I'm not sure if they're engineered microbes, but microbes that are applied to the I guess the seed, and they grow on the roots there. So it's a asymbiotic form of nitrifixation. Frankly, measuring that difference, because it's not, they don't produce a lot of nitrogen. It's 20 pounds, 25 pounds of N. I can tell you, measuring a difference of 25 pounds of N at a field level in a production field is very difficult. And so, and therefore, independent validation of technologies like that become very important. And that's something I'd like to also stress, that companies that purport to have products that make a difference here, it's very critical that we have independent validation in production fields done by people that are not the people that are producing and selling the product. So I hope that gets at what you asked someone.
Yeah, no, that's great elaboration. Thank you for that. We have a question in from Slack that I think maybe answerable by, or at least be able to be commented on by the both of you, but we may also, if any of the other economists present with us would also like to take a crack at it, by all means, please raise your hand and we can bring you onto the screen. And there's multiple parts to this, so I will read slowly. So the question is, do crop insurance policies actually provide what producers need? What is actually behind what programs / requirements are incorporated into crop insurance, crop subsidy policies? Are farmers at the table in the decision-making process, or is it more of a game of telephone from farmers through intermediaries to policymakers? And so some of the nuance of needs or support are lost. So I know there are a couple of things going on there. Ken and Bonnie, if you have any thoughts about all or some parts of this
I was going to pivot to Craig. I think Craig Cox should answer that question. Still on.
Thank you so much, Bonnie. Nice to see you. So that's a really complicated question, but the long and short of it is, within the Federal Crop Insurance Corporation, there are some basic policies that have been in place forever and are essentially run by the Federal Crop Insurance Corporation. But other entities can and often do propose their own new crop insurance policies. And if they can pass muster with the Federal Crop Insurance Corporation, those policies can be offered. The biggest issue is what level of subsidy is going to be provided to those individual crop insurance policies by the taxpayer. And that's really, in terms of which policies are going to be attractive to farmers, that's a major issue, but I think it's also a major public policy issue. Just for us, for example, is what is the public interest in subsidizing these various crop insurance products. And just one last thing is, since 2000, the crop insurance program has really largely been transformed from a yield insurance program to a revenue insurance program. So that's also been a real fundamental change. But I'm not sure I'm answering this person's question, but the way specific policies are made part of the Federal Crop Insurance Corporation and available to farmers is various.
I might jump in if it's okay, just a bit more clarification. I'm guessing that there might be some confusion. We keep talking about crop insurance linked to solutions for nitrogen problem. And that's because there is this thing called conservation compliance. So this is a I'm going to give you my simplest and probably incorrect, but conservation compliance is a set of requirements that if a farmer has a certain, like on highly erodible land, if they are going to get this subsidy, if we're going to help them pay their cost of their insurance, they have to agree to do something environmental. Okay, so it's kind of a contract between, we're providing you a subsidy, but we're getting something back for it. So this can be, considered a good public-private sort of deal. The question, so it's not that they're getting plenty of insurance, or they're making their own choice for insurance for their crops, just like we all decide how much health insurance we need. That's not the issue that's not why we keep talking about crop insurance. We're talking about it because it's a way in which the taxpayers have made a mutually beneficial deal. And lots of people, Craig and others and myself and others, have wondered whether there is enough public benefit from this deal. Farmers will argue that there is, understandably. Others will argue that maybe there isn't. So, but it is a deal that could be changed. And that's why it's being discussed here. Right now, the requirements for this subsidy is based on basically erosion, I think, kinds of things to prevent erosion. For the most part, those are not good ways to address nitrogen. It depends on places, and everything depends on context. So that's why it's always but if we were to get serious and think that we ought to make this deal about nitrogen, we could change those requirements. But of course, lots of people won't like that, and there'll be arguments about whether it, and so on and so forth. So I hope that clarifies why we're talking about insurance in this way. It's about the subsidy component of the insurance and the mechanism. I hope that's helpful, not confusing.
That was helpful. At least it was helpful to me, Kathy. Thank you. Jerry, you have your hand up.
Yeah, I've got kind of a philosophical question for Ken and Bonnie, and Craig could even contribute to this as well. But Ken or Bonnie, if you were king or queen, what magic wand would you take and put over a farming system that would solve this problem?
Easy question.
Yeah, I figured that, we've got a few minutes left. So, Ken said he spent 50 years working on this problem, and you can ask why he hasn't solved it by now. But, and so, what should we be doing? What should be some of the things that on the top two things we say, we need to go out in 21 and 22 and make these our priorities?
Bonnie, do you want to go first?
She's smarter than that guy.
So for me, it really does come down to data and ways in which we can accelerate the testing, the quantification, and innovation that occurs on farm, because progressive growers are optimizing a minimum of 10 and more likely 20 different management decisions, from their rotation, their tillage system, their time of sowing, the variety, all the different nutrients, the pests, irrigation, et cetera, et cetera. And being able to come up with the impact of one factor out of everything else is almost impossible. But there is a way. Imagine that every grower in the world reported the GPS in an anonymized database that's only accessible to them if they want to see how they perform against everyone else with similar conditions. Gets back to the spatial framework thing. We now have tools to say, if you're farming this field, what other fields in the entire world have climate and soil similar to that within a limit that means that if you change management, it will behave similarly on that field as well as the other cohort fields, so that you have thousands of field experiments every year on those cohort fields. So if you just reported those 10 to 20 factors that you're managing, the yield you get, bring in the soil, this soil and climate database we talked about. At the end of every year, you could see which factors were responsible for getting highest yield, best nitrogen efficiency. Now it varies by year. Remember, climate's varying. So what factors work one year doesn't work as well the next, but that all falls out over time. If there was this large global database of what farmers are doing that could be analyzed in a way that tells each grower what things worked on that piece of land the best. And if we then had better estimates of the nitrogen losses, as I mentioned earlier, based upon management, you could then also see what the impact of these factors were on. But I don't see, you can't do it by conventional field experiments that manage 2 or 3 variables at 6 sites over 5 years. That's no longer even possible. So I guess, Jerry, if I was the czar, I would try to get growers and industry to see the benefits of having this massive, large anonymized database that everyone could use to their benefit, including the private sector, that would be owned by growers. It would be a data cooperative. They would decide how it's used for their benefit. And I'll end there.
Bonnie, did you want to add? Or?
Well, I'll just say I think that's a great idea. I actually had conversations with the former executive of Cargill about creating something similar to that. So I think there's there would be a lot of benefit in having a way to collate that data and have it aggregated in a way that was anonymized, that limited some of that, but also provided an opportunity for comparison across watersheds and sort of leverage that social norm behavioral tool that we all know is useful. I think I know what Kathy would do if she was queen of the day, and I'm pretty sure I know what Craig would do, but maybe I'd give them a chance to say what their visions for the future would be. I still think about, so I live in an agricultural watershed. I'm surrounded by corn and soybeans, and I think about what it's like to live in these regions in a more holistic way, not just about the units of nitrogen that end up in the water and the air, but I just think about what does it mean to live in an agricultural community, and what kinds of agricultural communities do we want in the future? And so, I think things that like Lisa Schulte-Moore's work on prairie strips, where there's this real visible landscape change that people start to see and associate with what their landscapes could look like. And I remember going on walks with farmers where they were talking about the details of how much denitrification was happening. And they're just like, I just want to know where my kids are going to play. Like, is there still a forest patch in this woods? Like, because I just really like having that forest patch. I find mushrooms there. So I think we also need to provide a vision and articulate for people, what does the Corn Belt look like in 2050 or 2100? What do we want it to look like? And then we're leveraging a whole set of interventions that goes much more beyond just managing nitrogen. It's really thinking about our entire food system and how we develop a rural economy, and who's involved in shaping that vision, and how that affects our nutritional system and our food delivery system, and how resilient is that to climate change. And so, to really explode the boundaries of this problem, which make it infinitely more complicated, but I think also bring a lot of different kinds of different people to the table when you're really thinking about what does it mean to live in our agricultural regions, and how do we want them to be thriving, beautiful, healthy places to live in the future.
Thanks, Bonnie. That's great. I saw that Rochelle had her hand up. I don't know, but I don't see her anymore. So I don't know if she's still here. She's She may have left. Okay. Well, Rochelle, if you are here and I'm just not seeing you, please just raise your hand again and we'll put you into the queue. One thing I wanted to ask as a follow-up to both Bonnie and Ken on this idea of this really large anonymized database, if you will, of performance across different farms. Can you imagine something, kind of going back to what you were saying, that sort of like this era of 6 farms over 5 years is just not going to cut it anymore? Can you imagine something that would be meaningful but is not necessarily at the global scale? Like, could there be something like a meaningful pilot, but it's not necessarily global? So we're not talking about 6 farms, but maybe we're talking about 1 state. I actually don't know what the right meaningful scale would be, but something to sort of pilot and sort of show the potential of then expanding it out. What's a meaningful sort of size?
Well, we have some experience with that. So in Nebraska, which when the Clean Water and Air Act was passed in the early 70s, gave regulatory authority to comply to states. Many states did it at the state level. But in Nebraska, there was distrust of state government. So not only federal government, but of state government. So they delegated to natural resource districts that are essentially small watersheds, of which there's 23 in Nebraska, and gave them taxing authority, and they vote for board members, so their neighbors are on the board. And they said to the natural resource districts, you comply. And you know what the first thing they did when they had responsibility to comply? They required getting the data. And so we've plumbed that database and then gone back to the growers that, now we had to get their permission, and it's completely anonymized and it's in collaboration with them. But we've shown them that that database can be used in amazing ways to look at how they prioritize their decisions. We've also worked with the soybean growers and shown that you can identify, not with nitrogen, but just, for instance, when is fungicide working and why? You can ask questions. You see, you can pick out things that you can see effects of things that are one factor against 20 other factors. And they're all varying across farms because each farmer is putting together their particular management practice in its own way. And so I think it's been demonstrated, Jennifer, that this works quite well. It's a matter of, I think, getting buy-in. And there's such a mystique about data, about what its value is and who owns it, that really distracts, I think, from the key issue, which is some data are good, more data are better, and all of the data are incredibly powerful. And it can be organized in a way where its only purpose is to improve management practices at the farm level. And it can be under farmer control. But I just think it's a hard act to get. It's hard against the backdrop of the large corporations that all want to grab their system and their data, right? And they have a kind of a principality of their own data and their own users. And we're caught up in that system at this moment. And then distrust. We've heard the word distrust. There is distrust. You can't get away from it. But I think there's a way to do it. And I think ultimately it's the only way.
Going back to the behavioral science piece. Bonnie, I didn't know if you wanted to add anything, no pressure. Okay. Well, I see that Tom Burke, our EHMI chair, well, actually, until very recently, EHMI chair, now ex officio member, has a question.
Well, first of all, am I off mute? Okay.
Yes.
Okay, great. I've been having troubles with the internet. First of all, this is an amazing discussion. We're now in the 5th session. At points during today, hearing about the rural-urban divide and the mistrust issues, I was realizing why a long time ago EHMI picked not just nitrogen, but really a hard look at the food system and the health connection to be a focus area. We're taking on a wicked problem here, and so much of what we discussed today really gave great examples of why this is such an apparently intractable problem. But I really want to thank Ken and Bonnie for their perspectives, because there's nothing new under the sun. And just a few short years ago at EPA, I heard the same kind of intractable arguments about oil and gas exploration and fracking and the lack of data and where did it begin? And Ken, you're absolutely right. It begins with information and anonymized data sets, and the data are out there, whether it's on releases or best practices, but we need to really organize. We need to make the best of it. We need to present the metrics. And whether it's oil and gas exploration or going back in time for most of our environmental challenges, it really began with better information and awareness of things to allow us to quantify risks and benefits and start that forward. Now, I understand that no Secretary of Agriculture could ever get confirmed if they said, I'm going to take on nitrogen, right? We have an uphill battle here, but I think this discussion has been so rich. If we look at what information can be put out there, if we look at better understanding the cost, if we look at the system more broadly, and we identify those hotspots, which we've all known, and those communities that are so hard hit as priority areas, I think we can begin to put the pieces together to make progress. It's going to be a long haul, but I also think I heard in the 5 sessions that we have an unsustainable system given the trends, and particularly in a changing climate. So maybe this is a little bit of a commentary. I'm a public health guy, and I have to admit I've been a little bit shocked by the lack of concern in the agricultural community for the downstream public health effects, given the growing evidence. However, I think that is also a very important part of the metric. And as we put this together and perhaps look at the recommendations, particularly from this session, we can really make a difference by informing the decisions in the future.
Great. Thank you, Tom. So we're almost at close. So I think at this point, I'm going to hand it back over to Kathy to close out this workshop and the series. Kathy.
Thank you. Fantastic job, Jennifer, Elena. It's hard work. It's been a long day. It's been a long 5 weeks. So I'm not going to keep you very long, except to say thank you so much for those of you who stuck with us. This has really been a really great coming together of lots of different ideas, lots of different discussion, and I hope really communicating across disciplines and groups of people who often do not have this level of detailed communication. So I'm just going to close by reminding you that we will have a document summarizing, synthesizing. It'll be short. That'll be available this summer. And one more time, a heartfelt thank you to EHMI, the National Academy staff who did the heavy lifts, and all of you who have participated and put so much time and energy into presentations, comments, discussion on Slack, and so on. Thank you all. Be well and stay warm, stay safe.